Vertices with negative 2 and 2, 4, 2. So let's see here. Negative 2 and 2, 4 and 2. Co-vertices at 1, 1 and 1, 3. Gee, where's our center? It's nice when they have it right there, when you have the midpoint, where it's the distance just right, one above, one below. Woohoo! So we have a center. Our center, our H and K, will be at 1, 2. It's an ellipse being stretched left and right, so that means the A squared values will be underneath which one? If we forgot, we can always look it up. Oh. There we go. Whatever. Anyway, so we know it's going this way. Our distance from our A value, apps. Okay, look for conics. Your A value is distance from the center to the vertex, so this was 1, 2, 3. So A is 3. Our B value is 1. So our A squared is 9. B squared 1. And I believe, if I'm not mistaken, the A squared will be larger underneath the X squared to go left and right. Is that correct? So then I just write it out. I have X minus 1 quantity squared over 9 plus X minus 2, sorry, Y minus 2 quantity squared over 1 is 1. That's it. What's that? No. No. No, not needed. Yes, ma'am. 17. All right, so we start now by making a bunch of squares. 2, negative 3. 2 and 6. So we know it's going to be stretched vertically, so it's going to be a y squared, or excuse me, the a squared would be underneath the y value. Foci at 2, 0 and 2, 3. Bless you.
Thank you.
So my center is going to be at 2 and 1.5. It's the midpoint of 0 and 3. It's the midpoint of 6 and negative 3. So we just add them together and cut it in half. So our HK will be at 2 and 1.5. Remember, this is the one time that I say it's quite all right to use decimals because they're just easier to write with. It's trying to do all decimal or fractions. Our A value is center to vertex.
Wait, no.
So here's 1.5, 2.5, 3.5, 4.5. Our B value we don't know, but we know our C value is 1.5. So in order to work with an ellipse, the ellipse has a generic equation with a plus in between the two. So the A squared B squared will be minus B squared. Remember, it's always going to be the opposite. That's the easiest way to remember it. So we'll have C squared is A squared minus B squared. So 1.5 squared minus 4, or is 4.5 squared minus something. I think we did this yesterday, didn't we? Did we have one? Did we have an example where it was like 4.5 minus 1.5? Wasn't it 12? 18. That was something like that. So B squared is 12, and then A squared, don't tell me, is 20.25?
Yeah.
Look at me, I remembered stuff. Yay!
B squared is
18. Yes, sir.
You asked us if it was 12 or 18. We told you 18. You still wrote 12.
Oh, yeah. Sorry. Oh, whatever.
Catching mistakes.
Catching mistakes one at a time. So your final answer then becomes X minus 2 quantity squared over 18 plus y minus 1.5 quantity squared over 20 1/4 is 1. All right, set that sucker up. Let's talk about the fun stuff. When all else fails, what do you have to do?
Call G.I. Joe.
Where he never gives up, he stays till the fight is won. G.I. Joe is there. G.I. Joe to be American heroes. I had all that stuff. It was awesome. Now, when all else fails. When all else fails, we have to go back and look at how we're going to set up to put it into the standard form. What happens a lot of times with these is that you're going to be given this if this opens up. We're going to classify, which means figure out what it is.
What is it called?
Still 10-6.
No.
So this is the last bit of 10-6. This is the 10-6 on steroid portion. So what we're doing here is we're going to work through what's called classifying it. There are ways of classifying via the discriminant off this nasty setup of formula, but I don't believe that it's worth it because I'm still going to ask that you guys graph and label everything. So most of the time when I ask you guys to graph and label something, it's going to be in this specific format where you're going to have to adjust and set up and move around some of the parts to get to figure out into which one of those 4 formulas we have, whether it's going to be a parabola, hyperbola, ellipse, or a circle. Now, one of the easiest ones to distinguish between is always going to be the parabola, because the parabola only has what going for it? One of them squared. So if you know that you have a parabola and you only have, the obvious thing it'll be is that you're only going to have one square term. So right away, I know it's not a, okay. So we only have, we have a 1 in 3 chance now of guessing correctly. Yay! So here's what we're going to do. What we want to do is we're going to set and move things around. We're going to combine and put the x's next to each other, put the y's next to each other, and shift the constant to the right. We're completing the square a couple of times, is basically what we're going to wind up doing here. So 2x squared minus 4x plus y squared is 4. All I'm doing is moving things over. Okay? I'm moving things over. Now, the first step for completing the square was that you had only one rule to worry about. That one rule for completing the square was that your first term had, the a value had to be what? 1. Okay? So here's what we do. Here with the x's, the a value is a 2. Can't complete the square, so what I do is factor out the 2 out of these. So I get this. I'm just setting it up. Do I have to do anything with this y squared? Can't. Oh, I see what you're saying. Take out the 2x. What I'm trying to do is complete the square to get something squared here.
Oh.
Because one of the formulas has this setup. Okay. Now, the other part, since it's just plain old y squared, there's no plus y or anything, that's just going to have a k value of what? 0. Now, when we complete the square, we're going to have to add things to both sides of the equation. Remember that? Now, here's the other thing you have to be careful with when you have this factor that comes out. I took a factor out here, which means I have to put it back here.
Wait, what are you getting the plus to? That too?
We're going to add things to both sides.
Aren't you supposed to divide by 2?
Not yet. You'll see what happens here. Okay? You're going to see what happens here. I know, right? So this 2 stays here. And now I complete the square with the junk inside here. What's half of negative 2? Negative 1. What's -1 squared? So in essence, what I've done is by factoring out this 2 here, I'm able to complete the square with a relatively easy thing, which by distributing all this back in, I have to put it back to here. That's what that's doing. Okay? Yeah, Trent?
Wouldn't you have to factor out like the 2 from the y squared?
There is no 2 with the y squared.
No. But you still have to factor it
No,
out.
because I'm using distributed property here by just grouping it into here. I'm just dealing with this part here. There's nothing else I have to worry about with this y squared part. Okay?
So 2x
So then I get
plus y squared equals 8. No, sorry, 6.
equals 6. Okay? So now, what do I have to do with the 6 to turn that into a 1? And don't say subtract 5.
5 by 6.
What is it? Ellipse, circle, or hyperbole? It's an ellipse, very good. It's an ellipse. The reason that it's an ellipse is because your A and B values are different. If your A and B values were the same, it would be a circle. Now, which way is this stretched? It's stretched vertically, because my A squared term is 6, my B squared term is 3, which means my C squared term is
3.
3. Very good.
Can you go back up to like?
1/1000.
No, actually.
Yes.
When you're computing the square and you add to the other side, do you add just the original half of the b coefficient or the
It
square?
had to be squared. It just had, because you know I took -1 was half of b. Square -1, it's 1. That's what you're adding to both sides.
Wait, what happened to the 2?
Where? From the 2/6?
Yeah.
It's simplified to 1/3.
Oh.
So we're just simplifying things out, putting it into that form. Okay? So from there, it's a matter of graphing, which I know we can do. I'm not too worried about the graph. Bless you. I'm not too worried about the graphing stuff right now. I wanted to get us set up and going for it. We know the direction. We know how to plot. We got a center. It's pretty easy. Our center is at 1, 0. We'd have to walk a root 6. We'd have to walk a root 3 and label our points out. Okay? What I want to do is go through a couple of these with the process so that we understand how to set it up into this format to go from there. We okay with that? Or do you want me to graph this? Or are we okay with graphing? I think graphing is pretty easy. I think you guys are doing all right with that, from what it seems to me. Okay? Let's do another one.
How much material are you learning before Friday?
This is about it.
Okay.
And this part is just the one that just takes the longest because of all the completing square to
Oh,
it. That's all. It just takes the longest because of that. So we have 4x squared minus 9y squared plus 32x minus 134y minus 548 is 0. Yeah, good times. So, start out with it, it just looks awful. But in essence, it's really not awful. What's the first thing we're going to do?
Take out the 4 from 4x.
Ah, careful. Before we do that, what are we going to do?
We add
Yeah, move things around. This is the international symbol for move things around. This is the international symbol for help. Durka Durka. I don't know, remember the movie? No. I'm not going to repeat it. It's funny. Move things around. You all right with that?
No.
All I did is I grouped the X's and grouped the Y's. And now I'd start the process for completing the square. The process for completing the square states that the first thing you got to do is get your a value by, or take the a value to become 1. So I'm going to factor out a 4 here.
4 squared
Plus
plus 8x
blank.
plus
Move it over. Take out the negative 9, and I get y squared plus, I believe, 16? Bless you. So we have a 548. Now I took out a 4 times something. I took out a negative 9 times something, so I have to put them back on the other side. Whatever that a value comes out on the left, that a value has to go back to the right. That's the trick. Another trick is that if you are getting awful numbers, stop, erase it, rewrite the problem, and try again. You probably screwed up somewhere. You should not get awful numbers. These numbers generally work out fairly decent. There will be a time, or there are a few times here or there that things do happen, but not always. So we know that our terms are going to be 4 something squared. Well, what's half of 8? 4. What's 4 squared? 16 here and a 16 there. I do the same thing with half of 16. I rewrite minus 9, it'll be a y. Well, what's half of 16? 8. What's 8 squared? I put a 64 here and a 64 there. Here's 64, everywhere 64, old MacDonald had a 64. E-I. 64,000. Yeah, so it's here, 548 plus 64 minus 9 times 64. It equals 36. So all those nasty, gnarly, crazy looking numbers equal 36. And it's nice again. Yay! The land of happy numbers. Oh no, what do? I forgot.
Divide by 36.
The answer was 36.
Yep. And we wind up with x plus 4.
Quantity squared over 9 minus y plus 8 quantity squared over 4 equals 1.
Which is it? Probably were able to tell what it
It's
was
a
a long time ago.
hyperbola.
Yeah. The hyperbola shows up pretty quick with the subtraction sign.
Yeah, I still.
It's a hyperbola. X squared comes first. Which direction is this going to go?
This way. Oh, up and wait, it's hyper.
Left
Oh,
and
left
right.
and right.
Left and right.
I get confused because the first. Oh,
Because the
parabola.
parabola goes up and
Yeah,
down.
that's
Yeah.
right. That's what you said.
So, but remember, if it's left and right elliptic, the a squared was underneath the x.
Yeah.
So if the x squared is first, it also goes
A
up.
parabola. I remember that.
A parabola for x is up and down.
Nice. Do you need me to graph this? Are we okay?
No,
So, if you think about a problem when it goes to graph and list all your parts, quite literally, it's just adding a couple of minutes to it. You know, just getting the algebra stuff, trying not to make it too crazy. I'm trying to think if I have any really tough ones.
You guys like not work together, I guess.
Oh, let's see this one. Probably So, what are you gonna do first? Yeah, get the x squareds and the y squareds together. Now, on this first part then, your a value is a -9, so what do you have to do with the -9?
Take out the negative.
Take out the -9. Take out the paper and the trash. Or you don't get no spending cash. What's -36 divided by -9? +4, very good. Take out the 4. I took out a -9 times something. I took out a +4 times something. Yeah, there is kind of a dead giveaway sometimes. That there's a lot of 9s and 4s and things like that that move around. It's kind of what they do a lot with these numbers. Yes, sir.
Are you supposed to do y squared minus 4y?
What do you mean?
Never mind.
Just figure it out.
Yeah.
So what's half of 4?
2,
What's 2 squared?
4.
So we have -9, x plus 2. You square it, bring 4 here, and here. What's half of -4?
-2.
Square it, we have a 4 here, and a 4 here. So let's see, 164 minus 36 plus 16. So it's 164 minus 20. Boy, look at all these factors, 9s and 16s and 12s that keep coming back. It's like a bad penny. Divide it out. It's pretty obvious we're not going to be a circle because we have different values here. So we have x plus 2 quantity squared over -16 plus y minus 2 quantity squared over, what is it, 38? No, 36, thank you. Yeah, 24. What is it?
Ellipse. Yeah.
It's a hyperbola.
It says plus. Oh, the -16. But yeah. So if there's a negative, like bottom number, it's gonna be a.
Rewrite it. That's the trick. A lot of you guys will say, oh, it's an ellipse because it's a plus, because you will have forgotten that there was a -9 right there. Sometimes we're mean people, and we throw negatives in there to make you double check and double think what you're doing. Okay? I know. What can I say? Bless you. Okay. Other than that, there's really not much craziness to this. It's just a matter of completing the square. And I know completing the square can be a pain, but it's good practice. This is quite literally why I taught you guys how to complete the square, so that you can do these problems. Questions at all? We all right?
I just don't want to graph.
The graphing, once you get through all this, the graphing is pretty quick, because you guys are pretty good at that now. You know, then that's where we go with this. Let's get rid of this stuff and do this Thursday. We don't need to do this until Friday. We don't need 3 days to complete the square. Can we do this Thursday? Be done with it, yeah. Let's do it Thursday. Is that okay with you guys? I'm gonna call you, because even, and this is weird, 12th hour actually did some of this yesterday. They got ahead of you guys, which is weird. You guys are usually ahead of them. I know. So that just tells me that conics are kind of flying by a lot quicker than I thought they were, which is great. I have no problem with that. I'd rather you get fit to your schedule than you guys fit to mine, because I'm going to be here till June, so it doesn't have to be. If I get more stuff in with you guys, great. Not, whatever. I know where I want to be, but it doesn't matter when we get there. So Thursday? All right. Executive decision, it is so. Thursday. We will test Thursday. Would you mind rewriting that for me?
It's like any objections,
Here's the marker for you.
Will we still have like a review page tomorrow then?
Yeah, I got something maybe, ish.
review it Wednesdays.
I guess. Let's do this then. Let's do.
No.
You should put no school.
So this is still 6:29. It's 10:06. Do these 5.
It's like hard.
And when you do this, I want you to do everything. The whole spiel. Yeah. Graph and label everything. The whole kit caboodle. The whole 9 yards. Everything. Everything.
Is this the same thing?
Same stuff. Yeah, it's 6:28, 6:29,
You
something
have
like
to
that.
change theirs though too.
No, geometry they'll test on Friday.
No, that's not what I'm saying with the no school.
We can't do that. There's school on Friday.
No, there's not. It's not what the board says.
No, he's not. That's not what the board says.
I mean, I'm not denying.
Wait.
Yeah, get those 5 done. Do everything, guys. Go ahead and complete the square, get into standard form, and then a squared, b squared, c squared. List out your vertex, co-vertex, focus. If there's a directrix, put your directrix in there. If there are asymptotes, write out the equation of the asymptotes. So this might take you, maybe 25 minutes. I'm sorry.
It's a long
There's 16 minutes left of class, Mr. Matthews.
Well, then you should get half of it done.